Section 5.3, example 8, sketching the graph of a polynomial function. So sketch the graph of function f of x is equal to -2, x plus 3 squared, x minus 5. So to graph these, let's start with our end behavior. So with our end behavior, we have to first find our leading term. So to find our leading term, we're going to multiply all of those parts out. We have x squared, so we have 2x's there. And over here, we just have 1x that we're multiplying in. So we have -2x to the power 3. So with that, we have an odd number here. We have a negative, so we're actually flipping it. So it's reflected about the x-axis. And now let's write our end behavior. As x approaches -infinity, our function approaches what? So as we start putting really, really negative numbers in there, this part ends up being negative times a negative gives us a positive. So we have positive infinity. And now on the opposite end, as x approaches positive infinity, our function approaches. So as we put really big numbers in there, so positive numbers, this whole thing ends up being positive multiplied by that negative is going to be -infinity. So let's start sketching this stuff on our graph. So over here, as x approaches, looking at this part, as x approaches -infinity, our function approaches positive infinity. So we have some sort of arrow going up this way at this end. And as x approaches positive infinity, our function approaches -infinity. So it comes down in this direction. So there's our end behavior. Next, let's look for our x-intercept or our y-intercept. So our y-intercept happens when x is equal to 0. So we're going to evaluate our function at 0. So f of 0 is equal to -2 times 0 plus 3 squared times 0 minus 5. And let's see what we get. So -2 times 3 squared times -5. We have -2 times -5 is a positive 10. 3 squared is 9. And we have 10 times 9 equals 90. So this gives us the point when x is 0, y is 90. And just for the sake of graphing that, I'm going to say that down here is what we're going to call, or actually up here, it should be positive 90. Up here is what I'm going to call positive 90. So that's going to be our y-intercept. And lastly, we have to find our x-intercepts. So x-intercept. X-intercept happens when y is equal to 0. So we're evaluating our function at 0, or we're setting our function equal to 0. So we have 0 is equal to our function, -2 times x plus 3 squared, x minus 5. So our function is equal to 0 when each of those separate parts are equal to 0. So when -2 is equal to 0, doesn't happen, so we have no solution there. When x plus 3 squared is equal to 0, x plus 3 equals 0, x is equal to -3. So that gives us a point when x is -3, y is 0. I'm gonna put a little star here because this is multiplicity 2. Actually, let's put it here at the bottom. So multiplicity 2. And let's work on that last part. X minus 5 equals 0. We have x equals 5, giving us the point 5 comma 0. And now let's graph those 2 points. So -3. So 1, 2, 3. We have a point there, and also at +5. 1, 2, 3, 4, and 5. We had multiplicity 2 at x equals -3. So on this one here. So that one, our graph is not going to go through. It's going to bounce off because it's of multiplicity 2. We know it comes up here to meet our y-intercept. Comes back down this way for that x-intercept and meets up with our end behavior over here. And that's it. So we have everything that we need. -3 here, +5 there, +90 way up there. That's it. If you have any questions, please feel free to ask. Otherwise, bye.